All right, so we're going to take a look at exponential growth or decay word problems. So in this one, it says in 2006, a sample of radioactive substance had a mass of 550 milligrams. Since then, the sample has decayed by 7.3% each year. Let T be the number of years since 2006, and let Y be the mass of the substance in milligrams. Write an exponential function showing the relationship between Y and T. Now, we were looking at the standard form, which I should have probably put back on here. Oh, it's down here. You can actually see it again. So the exponential function standard form, we looked at this when we first started graphing these in the last section. So we have f of x equals a times b. Usually the standard form is an x, but in this case we're talking about time, so it's t for time. Let's kind of work through what they just told us. So each year, the sample decays by 7.3%. So that means that 92.7% remains from the previous year. Okay, so we get this number by subtracting the decay rate from 100%, because what I have is decaying by 7.3%. So if I subtract 7.3, then I'm left with 92.7% of whatever was there to start with. Okay, so that's definitely an important piece. You have to remember, we're not necessarily we're paying attention to 7.3, but the 92.7% is what is going to help us know what's left over. It's the percent remaining. So we can use this to calculate the amount of sample that remains. This percentage will need to be converted to a decimal form. Remember, don't type in percentages in your formulas because that will, cause some multiplication errors there. So the exponential function is f of x equals a times b to the t power. A is going to be our initial value. That's always the initial. B is the percentage of sample remaining. So that's why we needed to calculate that percentage remaining. And T, it represents our years. So now we're just going to plug it in because all we're doing is we're writing an exponential function. So we have 550 for our initial value. That was what we started with. And the percent remaining each year is going to be 92.7% of whatever we started with for that year. And then for t years. So here is our exponential function. We wrote it, and we're all done with this one. So we just kind of had to analyze a little bit, what's actually going on in this problem. All right, so we have one more here. So in 1999, a city had a population of 370,000 people. Each year since, the population has grown by 9.9%. So now we're growing, we're not decaying. So remember, on this one, we subtracted from 100 because we are decaying by 7.3%. There's less remaining each year, right? In this case, hopefully we can kind of make this connection. Since we're growing, we're not going to subtract this amount. Okay, so let's keep reading here before we jump too far. So let T be the number of years since 1999, and let Y be the city's population. Write an exponential function showing the relationship between Y and T. I should note that on the last one I did f of x and they were asking for y and t. So really I should have written this as a y instead of f of x, if that's what Alex is asking me for in this case. Since they're asking for an exponential function, usually we would write it as f of x. Just kind of keeping that clear. So f of x and y are interchangeable for when you're typing this into Alex. So each year the sample grows by 9.9%. So that means that there is 9.9% more than the previous year. We get this number by adding the growth rate to 100%. So we have 100% plus 9.9. So each year, at the end of the year, we're going to have 109.9% of what we started with. It's more. Okay, it's over 100%. Decay is less than 100. Growth is going to be more than 100. So we can use this to calculate the amount of the sample after growth. So the percentage will need to be converted to a decimal. Again, don't forget to convert it to a decimal when you put it into your formula, because otherwise, again, multiplication errors. If you're multiplying by 109.9, that's different than multiplying by 1.099. So the exponential function, we still have the same thing where a is our initial value, b is the percent of growth per year, and a t still represents time. So it's either going to be the percent of growth per year or the amount remaining per year if it's a decay. So now we're just going to plug this in. We have our 370,000 and we have our percent of growth per year and then t. So we wrote an exponential growth and an exponential decay function. basically word problem kind of an idea. Hopefully that helped, and I'll see you on the next video.